An experiment in a wind tunnel generates cyclic waves. The following data is collected for 44 seconds. We have the first column T, or time, second column wind speed, or V, and time is measured in seconds, wind speed is measured in feet per second. Let V represent the wind speed or velocity in feet per second, and let T represent the time in seconds. Write a sine equation that describes the wave. So we're going to use the following template. Y equals a sine of bx minus c plus d. And what we want to do is use time, or t, in place of x, and use wind speed, or v, in place of y, and get the following form. So v equals a sine of bt minus c plus d. And so the first thing that we need to do is understand that our given table does not have enough data for us to fully understand the pattern that has started to evolve here. But we can easily expand upon it. If we go ahead and look at our data values, we'll start in the t column. You'll notice that each one of these values increases by 11. So that means that we're taking a reading basically every 11 seconds. Then you'll notice over here that this is a cyclical column in V, and you'll notice that we start at 24 and end up back at 24. We go from 24 to 51, and then from 51 to 78, but notice that 78 will then lead to 51, which then brings us back down to 24. So we see that 24 is our minimum value and 78 is our maximum value. And we also see that it is cyclical, so it will repeat depending upon what t is equal to. So let's go ahead and create an extended table. So I'm going to come over here and write t and v, and then I'm going to go ahead and write the given t values that are already in the existing table. And I notice that the v values will go ahead and start the cycle over. So the next v value after 24 here is going to be 51. And that's going to correspond to a time of 55 seconds because I've added 11 to the 44. And so that we would continue to fill this out, and we would have 66 seconds by adding 11. And that would relate or equate to a speed of 78. The next one is going to be 77 seconds. And now we're going to start to go back down again in our cycle. And then finally at 88 seconds, we're back down at our minimum value. And so what we're going to do is we're going to use this in conjunction with the graph to figure out what our actual equation is. So let's do that. Let's go ahead and take the table and let's make a rough graph. We know that the time is positive, as it has to be, and we go from 0 to 88 on the horizontal axis. And then on our vertical axis, V, you'll notice that the minimum value is 24 and the maximum value is 78. So I don't need to start at 0 on my scale, neither do I have to go beyond 78. So when I go ahead and just rough in this graph, I'm going to do it like so. I'm going to go ahead and do the velocity values along the horizontal axis. And since I don't have to start at 0 for the vertical axis or the v-axis, I'm just going to indicate that I am skipping some values from this 0, and we're going to go ahead and start our graph at 24, and then we'll have 51, and then we'll be at 78. And so let's plot all of the points. First we'll have 0, 24, which will be right here. Then we'll have 11, 51, then 22, 78, and then 33, 51. Notice that we're now going back down. 44, 24, and now we're going to increase again. 55, 51, and then 66 will bring us back up to 78. 77 brings us back down to 51, and then 88 brings us back to 24. And now if we just fit a general curve to this, and like I said, it doesn't have to be perfect. I'm just trying to come up with a rough estimate of what it looks like, because I want to use this to go ahead and generate the A, B, C, and D values if at all possible. Now we know that A is our amplitude. And how do I determine what the amplitude is? Well, what we're going to do is we note that 24 is a minimum value and 78 is our maximum value, and halfway between 24 and 78 we're going to end up with 51, because this is plus 27 from 51 to 78, and then from 24 to 51 is also plus 27. So that means that I can go ahead and draw a horizontal axis through the center of this sine wave. And now I can easily determine what A is, because the amplitude is given from this point at maximum point down to this part right here. And it should be obvious that this value is 27. Therefore, I can easily state that A is equal to 27. Remember, it is an absolute value, so it has to be a positive value. Now, let's go ahead and consider B. Remembering that B works in conjunction with the period. And so what we're going to do is we know that the period, P, is equal to 2 pi over B. Well, in order to solve for B, I need to know what the period is. And what we're going to do is we're going to look for where the sine curve actually starts in this case. And so when we do that, we're going to see the following. That if we start at this point right here and go through this point here and this one, then this one, and then this one, we're going to end up with a single period of a sine curve. And that means that I'm going from 11 to 44. I'm sorry, 55. And that means that the actual period is 55 minus 11, or 44. So this thing repeats every 44 seconds, which means that if 44 is my period, and that is equal to 2 pi over B, B is equal to 2 pi over 44, which is equal to pi over 2. I'm sorry, pi over 11. And that simplifies to pi over 22. So I now know what A and B are. Well, let's consider what C is. We're going to use C in conjunction with B to find the phase shift, or the horizontal shift. So the phase shift, PS, is equal to C over B. We know what B is. We're trying to find C, so that means I need to use the phase shift. And so to use the phase shift, that means I have to understand how this thing has shifted either left or right. And we'll come back up to this and we note that the graph is actually shifted to the right so that my initial starting point is 11 units to the right of where it would be in a traditional sine curve of y equals sine x. So we've gone from this part right here over to this right here, which means that the phase shift is 11 units. So I can go ahead and write 11 here. And that's going to be equal to C over B, and we just found B to be pi over 22. And therefore, when I solve this for C, we find that C is simply equal to pi over 2. Which means that I still need to know what D is. D is your vertical shift. You're up or you're down. This is most definitely shifted up, so it's going to be a positive value, but how far has it shifted? Well, if we start our traditional sine curve down here at this point, we'll see that this thing has shifted up to here, and that would be a vertical shift of 51. So now I know what A, B, C, and D are. And we'll go ahead and write out the form. V will be equal to 27 times the sine of pi over 22 t minus pi over 2 plus 51.